All right, if you're a developer, you know this feeling all too well. You've poured days, maybe even weeks, into a project. It runs flawlessly on your machine, so you ship it, you hand it off, feeling great, and then you get that message, the one that makes your heart sink. Hey, it's not working. Well, today we're going to talk about the tool that was literally designed to end that nightmare forever. We're talking about Docker. So here's what we've got on tap. We're going to start by reliving that shared nightmare, the "it works on my machine" problem. Then we'll see how a better way finally arrived. After that, we'll get into the nuts and bolts of how Docker actually works. I'll even walk you through the commands you'll use day to day. And we'll finish up by looking at how this one little tool completely revolutionized, well, everything. Okay, first up, let's talk about the pain. Because every single developer on every team has been right here. It's that moment of total confusion that leads to maybe the most infamous line in all of software development. Oh yeah, you know it, but it works on my machine. We've all said it, we've all heard it, and we all know what it means. It means the project has just hit a brick wall because of some tiny, invisible difference between two computers. It's the sound of a deadline screaming past you while you just want to pull your hair out. And here's the classic culprit, right? On your laptop, everything is perfect. You're running the latest Python 3.9. You've got library version 1.2. It's all good. But the server? Oh, the server is stuck back on Python 3.7 with an older library. And that's it. That tiny difference is all it takes for your beautiful code to crash and burn with a critical error. This, my friends, is what we call dependency hell. So yeah, the whole industry was desperate for a real solution. We had to find a way to create a consistent environment that worked everywhere. For a while, the best we had were virtual machines, or VMs. Imagine running a whole separate computer with its own entire operating system inside your main computer. They worked, sure, but they were so heavy. They were slow to start and would just eat your computer's memory for breakfast. We needed something way, way smarter. And that smarter, better way was Docker. It just popped up and completely changed the game, offering a new way to package and run our apps that tackled all those old problems of consistency and efficiency. And this right here shows you the secret sauce. A VM, that big clunky thing, has to boot up an entire guest operating system. But a Docker container, it's much more clever. It just shares the core, or the kernel, of the computer it's already running on. And this is a huge deal. It means containers are incredibly lightweight and wicked fast. We're talking megabytes instead of gigabytes. Startups that take seconds, not minutes. This was a total game changer. So where did this amazing idea even come from? Well, it actually started as an internal project at a company called .cloud, led by a guy named Solomon Hykes. In 2013, they decided to release it as open source. And boom, the developer community went absolutely nuts for it. It took off so fast that by 2015, the whole industry had to get together and create the Open Container Initiative just to create some standards around it. And this became Docker's mantra. Its simple, beautiful promise. You build your application one time, package it up in this neat little box, and that box will run exactly the same no matter where you put it. Your laptop, a teammate's computer, a cloud server. It just works. This fundamentally changed how we ship software. Okay, so we get why Docker is so great. But how does it actually work under the hood? Let's break it down. I find it helps to think of it like you're cooking a meal. At its heart, a Docker container is like the perfect lunchbox for your app. It doesn't just hold your code. It holds everything your code needs to live and breathe. The right programming language, the exact library versions, all the config files, everything is packed in there together. You can hand this lunchbox to anyone, and they can open it up and it'll be perfect every time. The whole process is really just a three-step dance. It all starts with a Dockerfile. Just a simple text file. That's your recipe. Then you use that recipe to build an image. This is like a snapshot, a perfect blueprint of your app. And finally, you run that image to create a container. And that's the final product, the actual running application, the meal made from your recipe. So first up is that Dockerfile. This is literally just a list of instructions. Step 1, start from the space operating system. Step 2, copy my application code inside. Step 3, install these specific dependencies. And step 4, when you start up, run this command. It's like an automated instruction manual for setting up your app's entire world. Now, when you follow the instructions in your Dockerfile, you create an image. And here is where it gets really smart.
An image is made up of layers, and each command in your Dockerfile creates a new layer. So if you only change one line of your code, Docker is smart enough to only rebuild that one tiny layer. Everything else stays cached, which makes your builds unbelievably fast. And finally, we get to the container. This is the real deal, the live running instance of your application. It's what you get when you fire up an image. You can start them, stop them, and create as many as you want from a single image. This is amazing for scaling up because you know every single container will be an identical, perfect copy. All right, enough with the theory. Let's get practical. What are the commands you're actually going to be typing into your terminal? Let's look at your essential Docker Toolkit.
Think of this as your cheat sheet. You'll use Docker pull to grab a pre-made image from the internet, like for a database. You'll use Docker build to create your very own image from your Dockerfile. Docker run is the magic word that starts a container. Docker PS is how you check what's currently running. And Docker stop and Docker RM are for cleaning up when you're done. Honestly, these 6 commands are like 90% of what you'll use every day.
So what's the big picture here? Why did this little container tool completely transform the entire software industry? Let's zoom out for a second and look at the real impact it had.
Well, the effects were massive. For starters, we finally had reproducible environments, which killed the works on my machine bug once and for all. Teamwork got so much faster. A new developer could get an entire complex project running with just one command. It fit perfectly into our automated build and deployment pipelines, known as CI/CD. And it basically paved the way for the entire microservices revolution, where we built huge apps out of tiny, independent services. And the community built around it is incredible. There's a place called Docker Hub, which is basically GitHub, but for Docker images. It's a massive public library with hundreds of thousands of pre-built images for databases, programming languages, tools, pretty much anything you can think of, all ready for you to just pull and use. The adoption numbers are just staggering. We're talking about more than 20 million developers using Docker every single month. This isn't some cool niche tool anymore. It's become a fundamental skill for modern software development, right up there with knowing how to use Git. So we've come full circle. Docker delivers on that dream of true portability. It packages your code and its entire universe into a single, reliable unit that just works, finally putting that old developer headache to rest for good. You know, when you stop wasting hours fighting with weird environment issues, you get all that time back to do what you actually love doing, building cool stuff. So that leaves just one question. Now that your code can truly run anywhere, what are you going to build next? And that's a wrap on our tour of Docker. I really hope this explainer helped clear things up. For more tech tutorials and developer roadmaps just like this one, make sure you subscribe to us here on the Duo Blocks Edx YouTube channel. Thanks so much for watching.